Hello everyone, hope you're fine. Well, in mathematics, we'd like to continue from where we are, and actually we are going to start a new topic, and this is calculus. We just finished statistics, but there's a video pending for that, so don't worry, the video will be sent, okay? So let's look at this new topic, actually, calculus. Basically, this is a new topic in syllabus D, but it has been in existence for those who have been doing additional math. It's a very simple topic. At the same time, it's a cardinal topic, even beyond your studies. Okay. I would like to take you a little bit back to some of the topics that we've done. And these topics are indices as well as coordinate geometry. Okay, those are the two key topics that you have to consider before looking at this calculus. Very, very important. Okay, so I will advise you to go through the same videos that I sent on those two topics, so that maybe you may refresh up your mind, and then calculus will be very, very simple to you. Right, so if we are to look at, first of all, coordinate geometry, that topic, coordinate geometry, or the coordinates here, we were able to calculate, if you remember perfectly well, able to calculate the gradient. Here. We are also able to calculate the midpoint, distance, the equation. Okay. Now everything under coordinate geometry was about a straight line. Everything under coordinate geometry is about the straight line. So take for instance finding the gradient. The question is always find the gradient of a straight line. Find the gradient of the straight line, right? So if we have a straight line of this kind, and then we've got 2 points. We've got point A here, point B there. Maybe this point here, point A, is 2, 3. Then the other point here is 5, -7. Find the gradient. We were able to apply the formula for gradient to say gradient, which is m, is equal to y2 minus y1 over x2 minus x1. Meaning, change in the y-axis over change in the x-axis. So, if we are to draw the Cartesian plane of that manner, we are looking at if we are to draw the Cartesian plane, maybe we say this is the Cartesian plane there. Then we've got 2 points. This point here, okay, let me put it here, this, and the other one there. Then we join the 2 points. We've got point A, point B there. And then these are the points we are referring to. Maybe this one is 2, 3, then the other one, maybe we say 5, 7. Then, when finding gradient of this, you are using this formula. It is always change in the y-axis over change in the x-axis. Change, that means minus in between, alright? So if we are to get back to this, we are saying if I are to make a triangle, a right angle triangle, then it will be of this kind. See that? So this change in the y-axis, this is the y, and then this is the x-axis, okay? So this change in the y-axis here, divided by the change in the x-axis, that is what we are calling gradient of the straight line. The question we have now is, how can we find the gradient of a curve? That's a question we did not mention there, okay? Because the other thing that you need to take note here is that as long as it is a straight line, the gradient at any point is the same. At any point is the same. If I had to extend this line the way it is, if I had to extend this line, and then I've got this coordinate, I can have another one, I can have another one, I can have as many points as I want in that same straight line. If I had to pick this point and this point, find the gradient, the answer I'll get, it will be the same as picking this point, as long as they're in the same line. So the straight line have got same gradient. Is it the same case when it comes to a cave? That's a question we want to answer. Is it the same? Does a cave have the gradient at any point? Let's look at this cave. We have the Cartesian there. Then we have, this is the y, this is the x. Then I've got a cave. We now put in again what we call quadratic function as well as cubic functions. Okay, so I've got this cave. Let me say that maybe the cave is equal to 2x squared minus 3. Okay, just there. As an example. This is the cave, quadratic. Will the gradient be the same at this point? Same here, same here, same here? Would it be the same? The answer is no. A cave has got the gradient at its own point. That's why if you remember very well, when we were looking at this, there was that part where they ask you to find the gradient of a cave at a given point. They'll always give you the point, right? They'll say, find the gradient of the cave at t or where x is equal to somewhere. They'll give you a point maybe where x is equal to 1. Meaning they want the gradient at this point. So if we are to say x is equal to 1 is here, then they want you to find the gradient at this point, because the gradient at this point is not the same as the gradient at this point. The change is different. You see? So at this point, with that method, we were drawing a what? A tangent at the given point. That's the method we are using, right? So we are drawing a tangent. By drawing a straight line passing through the same point. You draw the straight line of that kind, right? We're drawing a straight line. After drawing a straight line, we are getting any 2 points in that tangent. So you can get this, any 2 points, because you can get any 2 points because the tangent that you have drawn is a straight line. And I'm from saying a straight line has got the same gradient at any point. So after getting the 2 points, that's when now we are using M1. That's when we are using M is equal to Y2 minus Y1 over X2 minus X1. Okay? Now, the cave, again, it will always be different. You may not be as accurate as it is required in the exam. Okay? You may miss out due to some errors and other things. You may miss out. It may not come up the exact way they want, okay? But you may be closer to the correct thing. So in that case, the gradient always there, they will say, estimate. You are estimating. You are just going closer to the correct answer. Okay, they will say, estimate the gradient of a cave at where x is equal to 1. So you draw this. You are just estimating. Even the points you are getting here in this tangent, they will not be as correct as it's supposed to be. They are just approximation, okay? You are just estimating the gradient in that given or drawn tangent, right? But calculus is here to answer such questions, whereby you can even get the gradient, the exact gradient at any given point. So in short, calculus actually is based on finding the gradient of a cave. Finding the gradient of a cave. So after I teach you here, after we go through calculus here, I can even ask you to use calculus to find the gradient of a cave under the quadratic or cubic function that will be given in the exam. Then using maybe the tangent, just use calculus there. It will give you the exact one. But this one will give you the estimated one, which will still be correct, to be considered to be correct, okay? But calculus will give you the exact one. So in short, calculus, these mathematicians who came up with this idea, like in the Isaac Newton, who contributed much in the development of this calculus, okay, had to make some research on how a cave behaves, and they concluded that a cave has got the gradient of a cave differs at any point. At this point it will be different. At this point it will be different. At this point it will be different. Just like that. Okay? So that is what we are to learn here. Okay, so basically that is what we are to learn here. It's a very, very interesting and simple topic, but it's why those who are doing engineering, education and other things, they use a lot of this topic, calculus. Okay, so that is the brief actual introduction that you need to understand basically before we go into details of calculus. Okay, probably we can move from here. We can move from here. When it comes to indices, I will ask you to go through the 2 videos that were published under that topic, because application is also needed in here, especially where the laws of indices are concerned, okay? Whereby we said any number of variable raised to power 0 is equal to what? I can have maybe 2 to the power 0. This is always equal to what? 1. We need this. And then also whereby we said for fractions and negative indices or exponents there. Whereby we said we have 2x negative 1. Okay, 2x negative 1. Indices, we said negative means what? I said negative means 1 over, okay? So if it is in this form here, then we are saying 2 as a coefficient on its own, and then I can change this, the x negative 1, okay, in fraction form, where I'll say the negative on its own, that will be 1 over then x. Since this is power 1, it will just be 1 over x, where now this, the entire thing here can be written, where there is this, I will be able to substitute this, I will write it in that way, and then this now is the same as writing 2 over x. So when you see this, 2x negative 1, that's the same as 2 over x. We'll also ask this to be considered under this study, calculus. So let's try to see how we can answer some questions or the examples under calculus. Well, the first one. Example. The first one will say, find the gradient function. Find the gradient function for y is equal to 2x squared minus 3. Then the question continues to say, hence find the gradient, at x is equal to negative 2. So this is the question, the first question there. So we are told that we have to find the gradient function as well as the gradient, 2 different things. But what do they mean by that? I said, if you have, this is the curve, okay? That's a curve, it's not a straight line. So, if you have a Cartesian there, then we have the curve, and then this curve is 1 is equal to 2x squared minus 3, okay? And then, I've been asked to find the gradient at x is equal to negative what? X is equal to negative 2. So I'll say, at x is equal to negative 2, maybe let me say x is equal to negative 2 is this point here. Okay, I'll say maybe that is the point, or I can simply say, put it somewhere here. This is the point, negative 2, where x is equal to -2, right? Then in that method, actually we have to draw a tangent of that kind. And then after drawing the tangent, then we can get any 2 points in here. Then we use gradient is equal to m2. Gradient is equal to y2 minus y1 over x2 minus x1. So now that is not what we want to do. We want to go direct and find the correct answer, because this one here will just be an estimate. So how do we do that? So well, we are told that y is equal to this, right? So to get the exact gradient, we have to differentiate. This is what we call differentiate. We have to differentiate the given equation or given polynomial, whatever you be given. The first thing is to differentiate. So calculus actually for syllabus D is divided into two. We have the differential calculus. So the one I'm doing here is differential calculus. Then the opposite, the opposite of differential calculus will be integral calculus. Okay, so in the next video as well will go in that way, right? Where I think you've seen already in some questions where you are able to see this kind of symbol. Okay, maybe they put it in that way, dx there. This is integral calculus. Okay, so what we are doing for today, that is a differential calculus. So to get the gradient of this curve at this point, the first thing to do is to differentiate the given polynomial or the given expression or the given equation. That's the first thing that you need to do. The question you are going to ask is, how do we differentiate, and what's the meaning of that? What's the procedure? So this is the way we differentiate. So I'll write the given first, the given equation there, which is 2x squared minus 3. Okay? Then we start differentiating, meaning finding whatever we are going to differentiate, we have x. Okay, so the differentiated expression, that is the one that we are going to call gradient function. Okay, so this is the way to go. So to differentiate this, you will write dy over dx. Dy dx, meaning difference in y, gradient, remember it's gradient, okay? Difference in y over difference in what? X, dy dx. If you see this, then we are saying we are differentiating. We are finding the gradient function. Okay? In exam, this is not the only way that they use. Okay? It has got a lot of meaning, but same procedure. Whatever we're going to do here is the same. So when they say differentiate, you just use the word differentiate. It's the same as finding gradient function. When they say find the derivative, it's the same thing. Okay? Even when they use the word, they use the function to say find this. You see this? It's the same thing. That means you have to differentiate. So I've said they can use the word differentiate. They can use find the gradient function. Then they can say find dy dx. Then they can say they can use this. It's the same thing. You don't have to be worried. It's the same thing. I've put this, not this. This means inverse of the function. But when you see 1 here, I mean a slanting 1, that means differentiate. Okay. So now, how do we go about it? I'll be very, 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 very slow so that you understand well. Maybe some of you are encountering this for the very first time. Well, so dy dx will be equal to dy dx. And let me also make mention to you that it's not always dy dx, I mean the letters. Okay? They can use any other variables. If it is in v, like v is equal to 2u plus 4. Okay? Here you are not going to write dy dx. In this case, it will be dv du. Because you are differentiating v with respect to u. Here we are differentiating y with respect to x. That's the meaning there. Okay, so the procedure is this. Slowly, the coefficient here should always be multiplied by the power. That's the first thing. So you multiply the coefficient, meaning the number standing in front of a variable, whatever variable you're given, you always need to multiply by the what? The power. So in short, I'm saying 2 times 2. You write here. No, so I'll write it slowly. 2 times 2. You see? And then after multiplying, I'll write the variable x. X here. Then this x has got power what? 2. Always subtract 1. Always subtract 1 to the what? Power. Interesting. So, what I'm trying to say here is we've got the 4 operations, mathematical operations. When we say operations, I'm talking about these. We've got these 4 operations there. Then the way they are divided under calculus is in this way. Differential calculus here takes up multiplication and the subtraction. So you multiply, then you subtract. Then the opposite will take up addition and the like that. So these two here is differential. This is differential. This will be differential. Okay? Then the remaining two, positive or plus and division here, will be integral. Okay? Integral. To be integral calculus. Okay? So what we are doing here is only subtract, multiplication. But always it should be multiplication that you need to begin with, then subtraction. Hope we are together there. So that is the reason why some expressions, when you are given some expressions there, you need to always to change them so that the x is always coming behind the number. You should always have the coefficient. Alright, so you see some examples as we move on. So always I said you multiply this times this. After multiplying, then x here has got power 2, always subtract what? 1. That means you have differentiated this. Differential calculus is differentiating each term given. Each term must be differentiated. So I'm done with this. I'll go to the next term. I only have 2 terms here. There's this and this. I'll go to the next term. I'll write minus here. Minus 3. This 3 here. The rule now that I'm supposed to tell you here is this. The way we have that index law, which says any number raised to power 0, even if the number of variable raised to power 0 is always what? 1. Do you remember that? Here, under this, if you are differentiating a constant, meaning just a number without a variable, that's a constant. So the way it is here, this is a constant. So if you are differentiating a constant, the answer is always 0. Differentiating a constant, the answer is always what? 0. Take note of that. So don't have to even waste much time here. I'm differentiating a constant, a number without a variable. It doesn't have x, So any number, as long as it's a constant, the answer is always what? 0. Interesting. So I've got this, I've got this. Then I'll simplify this to have my final answer. I'll say dy dx is equal to 2 times 2 gives me 4. Okay? Then x here, 2 take away 1, that will just be 1. So raised to power 1, actually we don't write like that, okay? We don't write. This is more, there's like repetition. Okay? So meaning the entire thing here will give me 4x. This 4x is my gradient function. Gradient function. This is how we find gradient function. So whether they say find dy dx, the same thing. Find the derivative, it's the same thing. Okay, so now you have gradient function. After finding the gradient function, we need to find now the gradient at this point. We are told that where there is x now, you make that replacement, which is negative what? 2. So you don't have to replace this in the direct one. No, first differentiate. Okay. When you learn perfectly well with this, such steps you'll be avoiding like this. You just say this and this 4. Reduce 1 to x. Constant 0. Okay? It gives you that. So now that we have gradient function, now we can have the gradient. The actual, the exact gradient at this point for this case. How are we going to do that? So we are going to say the 4x now. I will replace where there is x. I will put what? Negative 2. So I'll say gradient will be equal to 4x. And then I'll say where x is equal to negative what? Negative 2. Where x is equal to negative 2. So I'll say 4. Here I'll put negative 2. When substituting, remember must be in brackets. And then this gives me negative 8. So this is the gradient. So even if you use that other method, you find that that method will give you maybe 7.4 what and what. Okay? But if you are exact, this is the exact answer. Correct answer without any doubt. Negative 8. That is the way we find. And this is the best. This is not the only way or the method used. There is another method which we call the first principle. But in the exam it will just be open. Okay, the first principle whereby you have to take the limit, see what and what. But you go for the quicker methods, okay? So that in the exam it will just be open. They are differentiate what and what. Unless otherwise where it doesn't even exist to say differentiate using the first principle. But that is also important. You can also look at that. Well, we can move on to the second example. Well, let's look at number 2. You've seen it. If y is equal to 16x plus 1 over x squared, find dy dx. How do we find dy dx? We are finding, we are asked to differentiate. So this is the equation we are differentiating. Let's begin. So we have y is equal to 16x plus c. Okay? So now if you look at this equation, it has got 2 terms again. There's this term as well as this. This one is straightforward here. We can differentiate because I said you have to differentiate each term. If there are 4, all of them. 5, just like that. So here there are 2. 1, 2. 2 terms. The 16x is straightforward. 16x I'll be able to differentiate because the x, layman's language, the x is behind, right? Now look at this. It's in a fraction form. Okay, so meaning I have to fight to make sure that the x comes this side here before I differentiate. Okay, so that's where I said indices are needed in here. We have to write this in another way where x will appear this side. So the one I have there is 1 over x squared. Okay? How else can I write this? We learned negative powers and I said 1 over means what? 1 over means negative. So the 1 over here, this is negative in indices. So this entire thing here is the same as saying x is negative 2. I've changed it. 1 over x squared. The 1 over, this is negative, right? So on this, I'll put the negative here. So it will be like this, x negative 2. Okay, if there was any other number, like maybe 2, there was 2, we say 2 over x squared, like this. I could have written, first of all, I could have written this, the 2 to be in that way. Then I'll put it in brackets. If I put 2 here, the other number, the only number that I can multiply to this to get 2 is 1. Have you seen that? So, over the x squared. My interest here is to make here should be 1, because 1 over is the one that means it, negative. So, with this one in brackets now, I'll say 2, then everything here will be x negative 2. Because the 1 over is now negative there. Then I can say 2x negative 2. So this is the same as that. Okay, so you need to know these principles. Need to know how to go about them. Well, so let's change this now. The 1 over x squared, this is the same as x negative 2. We've changed it. After changing, that's when now you start differentiating. So now this will be dy dx. Okay, this is where you start from. I've started differentiating here. That's why I'll put dy dx, the one I'm calculating here, will be equal to differentiate each term. Okay, differentiate each term. So now this one here will be the power to this x is 1. Okay, so I said you always need to multiply the coefficient and the power. So to be 16 here times 1, that still remains what? 16. In that case, I can just write 16, right? So this times this will give me 16 here. Then I've got x, I've got x. The power is 1. Always subtract 1. Don't forget. Okay, so I'm done with this. I'll go to the next part. Plus this term here, it has got the coefficient of 1. It's the same as there's 1 here. So I'll say 1 times negative 2. See that? So I'll say 1 times negative 2. That will give me negative what? Negative 2. 1 times negative 2. That is negative 2 here. Then the x here, power, which is negative 2. Always subtract 1. Step by step. Then from there we'll say dy dx will be equal to, we can now find the answer to this. I'll have 16 here. Look at this. X 1 minus 1. That gives me 0, isn't it? So meaning the x is to the power 0. What did we say about the laws of indices? Any number variable raised to power 0 is 1. So this entire thing here will give me 1. So that's the same as saying 1 times 16, and that remains 16. It remains 16. So maybe to make things much easier, I can simply say, where I said when you are differentiating a constant, for example, differentiating 10, I said it's always what? 0, right? I will now say, when you are differentiating a number raised to power 1, just like 10x, the answer is still, in that way, it will just be 10. If it is 70x, the answer will be 70. This is what is happening here. So this one was 16x. So when we differentiate 16x, it will give us 16. Okay? Then now we can work on this. The positive and negative here, that's the same as giving us minus. Then I've got 2 here, then x, negative 2, negative 1. That gives us negative 3. Okay. We are almost there. We are done. We are almost there. Okay. What is just remaining is to change the negative part into a positive, so that because the question was in fraction form. Okay, but if you get that much confused, what and what, leave it here. There's no problem. You are done, already done. Now taking it back to the form in which it was, that requires me to change the negative to the fraction. Okay, the laws of indices, just the matter of playing around with them. That's all. So now the one I have here is, let me write it here. 16, so dy dx is equal to 16 minus 2 x to the power negative 3. So changing this now, I have 16 here minus 2, okay, 2, then this on its own there. Write it in brackets. The negative means 1 over. So this will be x to the power 3. Like that. Where I will say now, this is the same as 16 minus 2 times 1, that is 2 over x to the power 3. So you can leave it there perfectly well. That is your dy dx. That's the way to go. Number 3. Well, look at the third one. Differentiate x to the power 3, x cubed minus 2x squared plus x minus 3, everything divided by x with respect to x. So we are differentiating this with respect to x. How do we go about it? The first thing that we are going to do is to change so that it's in a normal way. That's the first thing. Not the way it is. We can't differentiate in that way. Okay, first of all, we have to change. Then that's when we'll be able to differentiate. So say this expression, the entire thing here, say y is equal to x to the power 3 minus 2x squared plus x minus 3. Everything is divided by what? X. Everything divided by x. But how do we change this? Remember addition of fractions, subtraction of fractions. Way back in baby girls, you will find that they were telling us this. 2 over 5v, another 1 over 2. Add. Same kind of application here. We are looking for the common denominator. We will not add this plus no. Common denominator first. You look at the numbers given there, then you look for the common denominator. So in this case, what will be the common denominator? So you can say 15 times that 30. So you can say 30 would be the common denominator. Then you start saying this into this 15 times that. We get the 15 there plus C. You continue like that, isn't it? It's the same thing here. Everything is divided by x. So I'll start splitting. So I'll say y will be equal to, it will now be x to the power 3 over x, because it's a common thing. So x to the power 3 over x minus 2x squared here over x plus x over x minus 3 over x. Everything in that form. Okay? Everything in that form. Then we now reduce those that we are supposed to cancel. We can do that. Okay? So look at this expression here. X, here there are 3 of them and 1 here. So I can cancel here, and here there I will remain with a 2. Okay? I'll remain with a x squared. So I'll say y is equal to x squared here. Then minus here, I'll say x here, x there. You see? So I'll remain with it, 2x here, plus x and x. This gives me what? 1. Minus this one here. I have to change as well. I have to make sure that the x comes this side. So I've got 3 over x, which will be the same as the 3. I can write it in that way, then 1 over x. See that? Then in this case, I'll have x, 3x, 3x negative 1. So this entire thing becomes that. Together, so minus 3x negative 1. It is now this expression that I'm supposed to differentiate to find the derivative of this expression. So well, we can now begin. I'll write it here. dy dx will be equal to, we have got 1, 2, 3, 4 terms in here. 4 terms that we're supposed to differentiate. So say y is equal to x squared. When we differentiate x squared, there is 1 here. So it will be 1 times 2. That would be 2. Okay, so that will give me 2. Then the x, 2, take away 1 there. See that? And this will reduce to 1. So I have the 1 which I can write, no, which you are not supposed to write. Okay, because that is reputation. So just say 2x. So we have differentiated the first one. You go to the next one. Minus the 2x. When I differentiate 2x, just 2x, what did I say? You just made with a 2. So when you differentiate that, it will be 2. This one will be 2. Plus, I'm differentiating a constant without the variable, without x. What am I going to have? If I differentiate any constant, it will give me 0. So I have 0 there. Then I'll differentiate the last part. It will be now negative 3 here times negative 1. So negative 3 times negative 1, that will give me a positive. And that will be positive 3 here. So this times this gives me the positive 3. Then x, here, x. Then I've got negative what? Negative 1 here on top. Negative 1, always subtract 1. As we've been doing to all this. Okay? Further, you now just work on me and the expression there, which you say dy dx will be equal to, this one has already been differentiated, so I need to remain just like that, 2x. Then minus, this one is 2, the 0 should not be part of our answer. Then the last part here, it will be plus 3x, negative 1, that is negative 2. Okay? Same signs add. Then the sign will be negative. So, I'm done with this. It's just a matter of changing now this to fraction form. That's the end. No need to differentiate again, nothing. So with that, I'll say 2x minus 2, 2x minus 2, then this entire thing here, 3x negative 2. I have to change there. I have to change where I'll say, where I need to say, it is 3x negative 2, right? Alright, so I'll say 3 on this on here, then in this part here. Okay, you see this part here, the x negative 2. The negative is 1 over. So I'll say 1 over. Then x squared. See that? Then this now will give me 3, that is 3 times 1, that is 3 over x squared. So this everything here will give me 3, that will be plus 3 over x squared. I'm done. This is the way to go. Simple calculus, isn't it? Well, let's leave it here. Next time, we'll build from there. Thank you for watching.